Let us consider the binary product of C2h point group. That is, C2h point group is having 4 different elements E, C2I, sigma h. Depending upon that one, you are having 4 irreducible representation, that is AG, AU, BG, BU. Then this irreducible representation is having its own matrix representation, that is given in the table as shown, and the transformation matrix is nothing but AU is nothing but a Z, and then BU is nothing but X and Y. Similarly, rotation matrix, that is AG is nothing but RZ along the Z axis, that is rotational vector along Z axis, and BG is nothing but rotation vector along X and Y. Now, I should study the binary products, that is binary products should be expressed in terms of x square, y square, z square, xy, yz and zx. Now, when I do x square is nothing but multiplication of x along with x along with x. For example, x is nothing but 1 minus 1 minus 1 1 for E, C2I, sigma h respectively. Suppose if I multiply 1 with 1, that is 1 with 1 minus 1 with minus 1 minus 1 with minus 1 1 with 1, you will get 1 1 1 1. That actually corresponds to AG, that actually corresponds to AG. Similarly, I should do y square. If I do y square also corresponds to AG. Z square also corresponds to AG. Z is nothing but multiplication of Z with a Z. Z with a Z, that is Z with a Z means 1 into 1, 1 into 1, minus 1 into minus 1, minus 1 into minus 1, that corresponds to AG. X and Y, multiplication of X with a Y, or that is operation of X on Y or Y on X. When I operate that one, you know that X and Y both are having same transformation, that is 1 and BU is a irreducible representation. Suppose if I do that one, 1 into 1 minus 1 into minus 1 minus 1 into minus 1 1 into 1, it corresponds to xy. Xy also corresponds to AG. Similarly, I should do xz. Xz means multiplication of x with a z, that is 1 into 1 minus 1 into 1 minus 1 into minus 1 1 into minus 1, that corresponds to BG. Finally, if you come to yz, y is nothing but y on application with a z, that is 1 into 1 minus 1 into 1 minus 1 into minus 1 1 into minus 1, that is you are having BG, it corresponds to BG. This corresponds to the this corresponds to the binary products of your C2H point group, that is tabulated, that is AG corresponds to x square, y square, z square, xy, and BG corresponds to yz and xz. Next, if you come to the binary products of Ci point group, as I discussed in the earlier video, Ci point group is having 2 different elements, E and I. That is, Ci can be represented in the character table. Ci can be represented in the character table as E and I, AG and AU, that is 1 1 1 minus 1, that it corresponds to translation vectors x y z, that is AU corresponds to translation vectors x y z, AG corresponds to rotational vectors Rx, Ry, Rz. Now, we shall consider binary products, that is x multiplied with the x, y multiplied with y, z multiplied with z, x with y, y with z, z with x. X is multiplied with a x means 1 into 1 minus 1 into 1, it corresponds to AG. Similarly, y 1 into 1 minus 1 into minus 1, that corresponds to AG, that is also z square also corresponds to the same AG. If you do the multiplication of your unidimensional vector, that corresponds to AU. Similarly, x and y both are same, that means x is also same, y is also same, that is I can write 1 into 1 minus 1 into minus 1, that corresponds to AG. Similarly, y and z both are same, that is y is y with reference to E and y with reference to I both are same, and z with reference to E and I both are same. Now, if I write that 1 into 1 minus 1 into 1, it corresponds to AG. Finally, if you come to one more, that is zx or xz, that is x and z corresponds to same it corresponds to same symmetry of elements, that is it corresponds to 1 and minus 1, 1 and minus 1, same character 1 and minus 1, that is 1 into 1 minus 1 into minus 1, it corresponds to the AG, it corresponds to AG binary products. It is tabulated, that is finally it is tabulated, finally it is tabulated in terms of binary products, that is BP,